In this demo, we will create the package body for the package specification we created earlier. We will see how to do forward declarations, overload subprograms, compile, execute, and drop package bodies, as well as understand stateful and stateless packages. Let us quickly review the specification again. We have defined a couple of constants, gActive status with a value of a and gInactive status with a value of I. Then there is a gbonus%, a global variable. dpt-not-found-ex is an exception. We have then defined a record type grec which has two fields, pprofit of type number and pdpt-name of varchar2. This is followed by a cursor gcur-get-dpt-id to get the department ID from the departments table for an input department name. Then we have three overloaded definitions of the calc bonus function. The first one taking pprofit and pdpt-id, both number types. The second taking pprofit a number and pdpt-name of varchar2. And the third taking in a record type prec of type grec. Finally, we have a procedure updateEMP taking in pemp-id of type number and pdpt-name of type varchar2. Let's compile it again. Let us start the package body as create or replace package body HR management as. Notice the body keyword to specify the body. First we have a cursor cur-get-sal which takes in pdpt-id and returns the sum of the salary from the employee table for that department where the EMP status is gActive status, which gets a value of a from the specification. This cursor has a scope only within the package body. Next is again a package body scoped procedure setBonus which takes in pprofit. It initializes gbonus% to 0. Next, using the if clause, if gprofit is less than 100,000, then we assign gbonus% a value of 1, otherwise a value of 2. Next is the function getBonus, which takes in pDepartmentID parameter. It declares lsal as a number variable. Inside, it refers to cur-get-sal cursor we declared earlier, passing in pdpt-id to fetch the sum of salary. It returns the fetched salary multiplied by the gbonus% value in the session at this time. Next is the implementation of the specification function calcBonus, which takes in pprofit and pdpt-id both of type number. Inside, it first calls setBonus, passing in pprofit to set gbonus%, and then calls getBonus to get the bonus using gbonus% value. It has an exception block where it prints the error and raises it further. Next is the overloaded version of calcBonus, which takes pprofit number and pdpt-name of type varchar2. It declares ldpt-id of departments.dpt-id %type. It reuses the cursor declared in the specification gcur-get-dpt-id, passing in pdpt-name to fetch the department ID in ldpt-id. Then it calls the first overloaded version of calcBonus, passing in pprofit and dpt-id both numbers, and returns the result. Next is the third overload of calcBonus, which takes in prec of type gRecord. Inside, it calls the second overload by passing in prec.pprofit a number field and prec.pdpt-name a varchar2 field. I wanted to show you how to use record types as parameters, especially when the number of parameters become too many. Next is the updateEMP procedure, which takes in pemp-id and pdpt-name. We declare ldpt-id of type departments.dpt-id and reuse the cursor gcur-get-dpt-id defined in the specification, passing in department name to get department ID in ldpt-id. This is how you can declare a cursor once and reuse it several times in different subprograms without redefining them again and again. If the ldpt-id is null, it raises the exception dpt-not-found-ex, which it can see as it is declared in the specification. Finally, it updates the employee table, setting the department ID to ldpt-id for the given employee ID. It commits the change. Then there is an exception handler section where we are catching the dpt-not-found-x, printing a message and raising it again. Finally is the package initialization section, which begins with the begin keyword. where we are initializing gbonus% to 0. This will be executed only the first time this package is loaded in the session, and HR management will end the package body. Let us click on the Run Script button to compile it. Now if you refresh the Packages node, you will see our package over here. You further expand it to see our body over here. You can double click to open the body. Over here you can make further changes, and then you can compile using the Compile button on top. If you notice, there is also a Compile for Debug option. If you use this, then you can compile your package body in debug mode. Here is how you can compile an existing package body in the debug mode by issuing alter package HR management compile debug body. Alter package HR management compile body will compile the body. Alter package HR management compile body PL SQL code type equal to native will compile the body in the native mode. You can remove the body keyword to compile both the specification and the body in one go. For example, alter package HR management compile debug to compile both specification and body in the debug mode. Similarly, alter package HR management compile to compile the entire package. Alter package HR management compile PL SQL code type equal to native to compile the entire package in the native mode. You can check the current settings of the package by issuing select type PL SQL warnings, PL SQL optimize level, PL SQL code type from all PL SQL object settings where name is equal to HR management. As you can see here, there are two entries, one for the package and one for the package body, and that both have warnings enabled for them. PL SQL optimized level is set to a value of 2 and PL SQL code type is native. Here I wanted to illustrate to you the importance of the order of declaration. So here is the same package, but I have changed the order of the procedures. Calc bonus is moved ahead. It refers to set bonus and get bonus, which have been moved after it. Let us try and compile it. Since these are local subprograms, when the compiler is trying to compile calc bonus, it does not know of these as they come later and gives the error that set bonus and get bonus not declared in this scope at lines 9 and 10. So either we can move their declarations before calc bonus as we had done earlier, or we can do forward declarations. This way, while compiling calc bonus, because of the forward declaration, the compiler will know of these and will not error out. Let us compile it again. This time it got compiled successfully. Let us modify calc bonus and let us rename p_profit to pprofit without the underscore. Let us compile it again. We get the error that subprogram calc bonus declared in the package specification must be declared in the package body, even though the number, order, and data type of the parameters was the same, but since we modified the name of one of the parameters, it was not an exact match. This highlights the importance of specifying the subprograms exactly as they appear in the package specification. Also, all subprograms in the specification have to be implemented, otherwise Oracle will give compilation errors.